Namaskar. Welcome to this session on network security and forensics. We have been discussing a lot about firewalls and the logs that the firewalls generate, etc. So, what we will do is we will try to go hands on into IPTables, which is used in Linux and does the work of a firewall. Before we go into the practical part of it, where we will look at the installation as well as the demo of IPTables, we will learn the basics of the architecture of IPTables, and we will also once we look at the demo, we will also look at what are the precautions as a network security specialist, okay, or a network administrator you have to take to ensure that you do not get your network blocked by putting this firewall. Say for example, you block yourself by putting a firewall, you are going to have a lot of problems later accessing the logs or other things. And finally, in the last module we will look at the logs and the different types of logs and a little bit of understanding about the log formats, etc. Why we want to do that is that we will be able to write some Linux scripts and automate the whole process of collecting the forensics evidence. So, let us start with IPTables. We will the whole session is divided into two parts from our point of view. So, we are going to integrate this IP logs along with the IPTables along with the logs that we are going to see. So, the next sessions will include a part of demo as well as if you want to do some kind of hands on you can do it, and finally, we will look at some theoretical part of logging. So, coming to the objective, okay, so for this module we will look at what is IPTable, what is the architecture of IPTables, and we will also look at what are called chains. Okay. So, essentially the idea is that you give a bunch of rules and these rules form a sort of pipeline in IPTables. So, that the packets go stage by stage from one rule to the other rule, and depending on what you have given as the rule, either to accept drop or log or whatever it is, you will the firewall will behave so according to what command you want to give. We will also see loading and unloading the kernel driver modules and all that will not be a part of this, because we will just look at the installation part of a firewall which will do almost all the activity, and the practicals definitely will look at a small example where we try to prevent a ICMP packet from pinging our system, or when you try to ping the other system you ensure that you can filter out the ICMP packets, and so you do not get a response for the ping. One of the places, and we will also look at some common configurations. Okay. So, how to block Facebook, how to block Facebook for a particular time or a Gmail or whatever it is. So, this will be a sort of a template which you can use in your organization to block certain websites. Okay. So, this is how the firewall programs progressed in Linux. Okay. Initially, we had in kernel 2.0.34 the IPFW ADM, okay, and then in kernel 2.2.x you had something like Ipchains. Then we moved to in kernel 2.4 we have IPTables, okay, and in kernel 2.6 we call it as something else. Okay. So, I mean essentially in general it is called as IPTables. Okay. So, what is IPTables? Okay. I think we had seen briefly about IPTables. Okay. It is a stateful packet inspection. Okay. The firewall keeps track of each connection that flows through it. Okay. So, we will be able to the advantage of using this is you will be able to monitor VoIP or FTP where I mean and TCP connections. So, you will be able to filter, take action based on what is the flow that is there in your network. Okay. It also allows filtering the packets based on MAC addresses or IPv4 or IPv6 addresses. Well, there are two different commands. For IPv4 you generally use IPTables, and for IPv6 you use IP6 tables. Okay. And this is very useful when you are looking at the in network, out network, and then demilitarized zones. Okay. The other thing that you can do with IPTables is you can look at the flags of the TCP header and take actions based on flags. You could also see you can have network address translation done with IPTables, so that you mask off the real IP address For example, any of the data that goes via your natural interface, I mean you can actually change the IP address of the interface so that the data goes to some other location. Okay, the advantage of using port translation is that you can have a NAT environment, okay, and many of you know that if you have a NAT environment, we are breaking the internet's policies, but to some extent, but then this provides somewhat secure environment for the internal machines inside the organization. Okay, you will also look at I mean this IPTables also provides failover functions. Okay, of course, we will not see a demo of it, but it is better to know that yes, it provides some kind of failover functions. It can do system logging, okay, and the log format has a certain format, so that it is easy for you to parse. It can also do a rate limiting. See, this is especially used when you have DOS attacks. Okay, see, DOS attacks actually send a lot of packets, okay, within a small period of time to ensure that your system fails or responds very slowly. So, you can also put a rate limiting feature with Firewall to ensure that you do not land up with lot of DOS attacks. The other thing you can do is it does something known as mangling, okay, like altering the type of service, okay, or the explicit congestion notification bits, etc. Okay. So, essentially if your network supports or the end system support explicit congestion notification, you can actually set a bit on one of the IP packets, and then on the TCP packets, and then there will be a end to end systems will take care of this explicit congestion notification and then try to rate limit between themselves. Okay. So, this is one of the first limits when the issue of mangling helps you in developing quality of service, and IPTables help you achieve it. So, what IPTables does is it provides a bunch of queues, okay, on which you can do some kind of processing. Okay. So, here are some examples. The first queue type is the filter queue type, okay, and the function of this queue is packet filtering. See, you can have a NAT queue type which does network address translation, or you can have mangle queue type which actually does the TCP header modification that we discussed earlier. So, this filter packet filtering, okay, has that can do three transformation chains in the queue. Okay. So, the first chain is the forward chain, okay, and the input chain and the output chain. Okay. So, the input chain actually filters packets that are coming to the firewall, okay, and the output chain filters packets that are going out of the firewall, and this is what I am talking about is for the queue type filter. Okay, and forward is whether you can send it to some other NIC that is or servers that are accessible to you by from the firewall, I mean through another NIC. So, this is filter packets to servers accessible by another NIC on the firewall. So, this is so I see one is I can whatever I process, whatever I send I can process, and I can also forward it to someone else. The next part is the next queue is the NAT queue. Okay, usually I mean this filtering queue is the one that you will use the most, because this is where the TCP connections and the IP packets everything come to you. Therefore, I use this connection for doing lot of work, okay, so like filtering, but and we will see we will use one of this output to ensure that whenever we do a ping we do not get a response. I mean we can block our ping packets. Coming to network address translation, okay. So, this is, as I told you, is for increased security of your internal network. Okay. So, the address translation actually occurs before routing. Okay. Therefore, you are able to block your IP address from getting known to the external world. Okay. This is one of the so this is actually a pre-routing stuff. You can also do it post routing, which is known as the source network address translation, and you can also do it for the output, okay, for packets generated by the firewall. Okay, and this is not much used in small office, home office environments. Okay. Similarly, the mangling is TCP header notification, and you could do pre-routing, post routing, output output input forward, etc. Anyway, okay, going on. Now, once you once I get the packet and then the packet has been filtered, now what is the kind of action we can take? Okay, here are 4 actions that you can take. Okay, one is known as the accept action. Okay, so with this action the IP table stops further processing of the data. Okay, the packet is handed over to the end application. Okay, So, that means it is like a pass through. Okay. So, I am accepting it, I found no problems in it, it has passed through all the chains and then I take it. The second one is drop the packets. Okay. The packet is blocked, it does not go to the the external agency, okay, or the application. Okay. And the third one is log. Okay. So, what it does is that it just logs and then the packet information information about the packet is sent to the syslog daemon for logging. Okay. And IPTables continues processing with the next rule. Okay. So, it logs and then the next rule is going to be accept, then it goes and accept it. If the next rule is going to deny, it just going to deny it, okay, or deny or reject or drop. Okay. Okay. So, the log, okay, you will have to put the log reason, okay, why you want to log the packet, okay, and the last one is the reject. Okay. It is similar to drop, okay, but will also return will also send a message to host sending the packet, okay, that okay, I have blocked your packet. So, and you can say why you have dropped the packet. Okay. So, this is used on I mean usually people use drop. Okay. Drop means the end host will not know why something has not happened. Okay. Here, okay, the end host will know that the packet has been dropped and the ICMP error message has been returned. As I told you, in NATs, okay, you can have source NAT, okay, and you can have destination NAT. So, the source IP address is defined as two source, okay, address colon address, and then you give what port to what port can be used for NAT. And finally, you can also have some masquerade, okay, where you used to do a source address. Okay. So, by default the source IP address is the same as that the firewall's interface, but then you can do a translation. Anyway, okay, so we will not look at all these things. We will all these things are slightly advanced, that will itself take a course on IPTables, but we will just take a look at the IPTables can have these kind of features. And this is the typical block diagram. Say for example, I get an input chain, okay, then I can pass it to deny state or I can pass it to routing state, and the routing state can do some kind of local processing and then send it to the output chain, or the routing state can send it to a forward chain, and the forward chain can also deny it. Okay. When it goes to the output chain can also deny it. So, it is a kind of when I give commands. Okay. So, I give a line. So, this is the first chain. So, in the input chain what do I do? After I process the input chain, what do I do? I mean either I deny it or I send it to another chain. So, then this chain what will I do? So, this is the way if you see the configuration file, you will be able to understand how you can pass from one chain to another chain. So, if you look at this, there are certain options for IPTables. Okay. -t tells you the which table. By default you have the filter table that we discussed earlier. You can also have the NAT table, or you can also have the mangle table, etc. And -j tells you to which chain I have to jump after doing the current processing. So, this will usually be the last line of the rule usually. I mean, and -a tells you that you have to append this rule to the end of the chain, okay, and -f is used to flush all the rules. Okay. We will see how -f operates, -a operates, etc. And -p tells you the protocol type, which can include ICMP, TCP, UDP, or all of them. Okay. Then within a protocol I will be able to specify the port. Okay. I will be able to even target a destination port or a source port. I could also target the type of packets like SYN, SYNAC, etc. Okay. I can actually specify both packet, port and type. So, I provide all these kinds of flexibilities within my rule chain. Okay. So, for example, ICMP, which we are going to look at commonly, usually we do a echo request and echo response. Okay. So, like I mean I do a ping of a machine. So, whether to find the machine is live or not. So, what you could do is it sends an IPMP echo request, okay, and if the machine is alive it sends a echo response. Now, I can block this to find out, see, because usually if we start doing a ping I can do a broadcast ping and all that and try to identify what are all the IP machines in the network with the IP address, okay, with the different IP address that are available. So, I can prevent ping flooding. Okay. So, because ping packets you can specify the packet size and that might actually take up the bandwidth of the network. So, all these things you can actually overcome, okay, using the filtering criteria that we discussed. So, here is an example. Say for example, it says IPTables -a output, okay, -p ICMP okay, minus minus ICMP type echo request minus j accept. So, it tells you that on the output queue, okay, if you have a ICMP packet, okay, and the packet type is echo request, then go the next rule you have to apply is the accept rule. That means, I am going to accept all the ICMP packets that goes on the output queue. If you look at the next line, it says IPTables, okay, minus a that append to the input queue, okay, same ICMP packet with the echo reply type, and that means you accept. Now, suppose I want to block, okay. So, I just have to use, say for example, I want to send a block all the ICMP packets that goes out of my network, okay. Then in the first command, okay, first rule where I say IPTables minus a output, that means it goes out from my firewall. So, I will say block or deny or whatever it is, okay. If you do that, okay, this packet will drop. So, I put drop, so that the packet gets dropped and it does not go out. That means, you will not be able to send ping packets from your network to another network, okay. Similarly, I can actually put a limit on how much of ping packets I can say. So, for example, in this case I say limit, and limit 1 by s, okay. So, what does it say is that 1 per second, okay. So, minus I and then ETH 0. So, you also have to say which interface you have to do it, okay. So, here you are specifically saying that on this Ethernet 0 interface you do not send more than 1 packet per second kind of. So, essentially what happens is here are some of the parameters, okay, other parameters that you have. Okay, I think the previous example actually tells you about how you should give a rule. Okay, here is another example. Okay, so where we can say that, okay, so use a filter table by default. If minus t is absent, then it's actually the filter table that you will be used. Then it says append to the input chain. Then it can say minus s 0 bar 0. Okay, so network address bar mask and so on. So this is the way you actually give a command. So here are some examples. So here input minus I, okay, the input queue, and then it also says interface is ETH1, the protocol is TCP, the source address is 192.168.56.1, and then the source ports are from 1024 to 65535, the destination address is 192.168.56.2, the destination port is 22, and then you accept all these connections if you get this established from here. Okay. Similarly, what to do with input. Okay. So, if you want to forward packets, here is an example. So, it can forward a packet to the internal from the internal interface to an external interface, okay, and the source address is whatever is given, the port addresses are this from 1024 to 65535, and then the states that you want to have is new, established, related, and when you get all these states you just go ahead and accept and forward it. Okay. And here is some of the logs that come out of it. Okay. So, you see this log has a timestamp, and then it talks about what is the kernel that you are using, okay, what is the input, what is the output, what is the MAC addresses that are used, okay, SR source address, destination address, length, and then type of service, etc. So, you can log whatever you want, and the idea is it writes into a log, and then you can just use our regular techniques to identify this whatever is happening. You can also do a log analysis. Okay, there are certain tools for this. At the end of the lecture, we will tell you there are certain tools which you can do. You can draw a lot of graphs, okay, based on firewall. So, for example, someone wants to query what are all the machines that we have tried, that users, internal users have tried to contact. Okay. Suppose someone in your organization wants to answer this query, whether users have gone to some websites which they are not supposed to go. So, you can actually develop a network of websites. Okay. There are tools available, and these tools make use of these logs that are generated. You can do an analysis of the logs, so it can tell you what port people have connected, what is the communication that has happened, etc. One of the things that you should do with firewalls is actually when you configure firewalls, you should follow certain rules, okay, for optimized performance. You know, if the rules are too long, I mean, it can actually slow down your performance. So, here are some thumb rules that you can follow. place loopback rules as early as possible, because you want to process them. It's loopback is what is locally generated, so you have to process them as early as possible. Similarly, since you are not going to do any processing with the forwarding rules, so keep them as early as possible. So the delay from the time you capture the packet and send it to someone else, it should be as minimal as possible. That is why you have the second rule. So these are all essentially common sense. Okay, so if you want to do it much faster, use the state and connection tracking modules to bypass the firewall for established connections. Okay, so that is the third one. So place rules for heavy traffic services as early as possible, because the rules are followed one by one, and if you place the heavy traffic services rules at the end, then the traffic has to go through all the rules. That will slow down your firewall. So these are all some steps which you have to take to ensure that your firewall works well. Okay, and you get optimized performance. And these are all just some thumb rules. At the end of the day, you might have to use your common sense to identify how to work with these firewalls. So what we will do is, we have now understood what is a firewall, what is IP tables, and so what we will do in the next session is we will try to put a small demo, okay, where it will tell you how to install firewall on an Ubuntu machine, and then once I install the firewall, how do I specify the rules, how do I configure it. We will show a very simple configuration of ping, okay, and how to flush the firewall and so on. Okay. Thank you very much.